to use the question and answer box or the chat to ask your question during the talk. And so for the first talk of the second session, I am very pleased to introduce Mark Trotter. So Mark is a professor in precision livestock management within the School of Medical Applied Science at Central Queensland University. And specifically today, he will speak about on-animal sensors for the detection of key behaviors to enable refined management. So Mark, whenever you are ready, you can share your screen and start your talk. Thank you very much.
Thank you. How'd I go? Has that worked at your end?
Yep, that's perfect. Thank you very much.
Excellent. Righto. So thanks for having me talk. So I'm just trying to get my slides to progress. Here we go. So just a little bit of, I guess, of structure of what I'm going to present about today. Give you guys a little bit of a mud map first of all, and then I guess give you guys a little bit of an introduction to who I am and what we do over here in Australia. And then a little bit of background. I thought it might be worthwhile to give you a little bit of background on the industries in which we work, the grazing industries in Australia. And then jump into some of the research that we've been doing, looking at sensor systems that are being developed and why we're doing that. And then look at some of the work we do around algorithm development for behavioural monitoring and how we sort of go through that process. And then briefly touch on what we think that the future will look like in this particular space. So I originally grew up on a dairy farm in an area on the mid-north coast of New South Wales. So that's sort of about halfway up Australia from the bottom to the top. We had a Jersey cattle stud, which was quite successful, but I spent a lot of time on my extended family's beef operations, and I had my own little cattle stud for a little while and bred Australian stock horses. So got a really good solid sort of grounding in the, I guess, the day-to-day management of livestock growing up, and then got really interested in that in terms of progressing that in my career. So I studied at the University in New England. There's one of those in the US and one in Australia. I was at the Australian one, did a Bachelor of Rural Science. I went banking for a little while to understand a little bit more about the money side of agriculture. Came back and did a PhD in pasture agronomy. And then I saw what was happening in the precision agriculture space, in particular in the cropping industry, and thought there's a lot of opportunities to apply that same sort of thinking, but in a livestock and particularly a pasture situation. And so I've been working in that area ever since. About 6 years ago, I moved up to CQ University, Central Queensland University, which is about halfway up from the bottom to the top of Queensland, if you know Australia. And I now lead a team of researchers here looking at a whole range of different tools and systems and technologies for improving livestock management in grazing systems. So we have a bunch of people that work with us here. We also have a bunch of people that we work with internationally, adjuncts and experts that we collaborate quite closely. And some of their work you'll see as we bounce through this presentation, but just a bit of an acknowledgement there. So just, I guess, a little bit of a quick introduction to the grazing industries in Australia, the area in which I do a lot of my research. If you're not familiar with Australia, we are a relatively dry continent. The northern part of Australia, which is where I am based, has typically a wet summer and a dry winter season, a wet and a dry. And as you go further south, that evens out, and it flips and becomes like a Mediterranean sort of climate further south, where you get your wet winters. But just about everywhere in Australia is really unreliable in terms of the rainfall. And so that's one of the big challenges for us. The grazing industries, the dairy industry in Australia, we have around about 6,000 dairy farms, averaging about 260 cows. It's probably gone up, probably gone down in terms of the number of farms and up in terms of the average herd size since I put those stats together. Most the feed is pasture based, but total mixed ration is sort of expanding to some degree, and 65% of the herd is Holstein. Our sheep industry, 40,000 sheep properties, or properties that have sheep. Some of them will be mixed farms with cropping. There's about 70 million sheep. It used to be a much bigger industry in Australia, gone down in numbers. 75% of those are merino, so fine wool. And we are the world's biggest exporter of lamb and sheep meat. And the beef industry, and this is where I'd spend a lot of my time, a lot of my research. We do research in sheep and goats, but certainly beef is a really big part of the research that we do. It's 47,000 farms, 25 million head of cattle. A breeding herd of ranges between sort of 11, 12, 13 million, depending on who you talk to. And it's probably one of the biggest agricultural industries in Australia outside of cropping. Most of our cattle are coming through some sort of grass finishing, but increasingly we're getting more coming through in a feedlot. 7th in the world for production, and 3rd in the world for export. So a lot of the value of our animals are coming through export markets to places like where you're sitting at the moment over in Europe. So in terms of where all the cattle are in Australia, there's a lot of numbers, particularly in Queensland, which is the state in which I'm sitting right now. So we like to claim that we are the beef capital of Australia. And actually, even if you look at the particular catchment in which I sit, the Fitzroy catchment, we have the most cattle of any catchment area in Australia. And so Rockhampton, where I'm now sitting, is known as the beef capital of Australia. It's our great claim to fame. But really, beef is a pretty significant agricultural industry in Australia, and a large part of that is certainly the breeding is based off a pasture or a grazing system. Northern beef industry, in particular, has some really big challenges. So this is where we have all the big cattle stations, and so cattle stations that are as big as some of the states in the US or bigger. Very low productivity in terms of the numbers per hectare. Bos Indicus cattle, so that Brahman type cow dominates, and pretty low quality animals coming out of that. Some real big issues and challenges in that environment. But really, there's some really big opportunities to refine the way we're managing our animals, and that's what we're doing, looking at research opportunities to do that. And so I guess the real focus of what we're exploring are these digital technologies in the rangelands. And the reason for that is, at the moment, people, the average producer in Northern Australia in particular, will put cows out into a paddock, and he may not see them for another 12 months. It may take 12 months before they come back into the yards to be managed, and a decision can be made about keeping or, say, selling that animal. And so the ability to observe and understand what's actually happening out in the paddock is really quite limited. And of course, if you don't have the information, you can't make informed decisions. And so that's where some of that inefficiency in these production systems is really limiting. But we think, a lot of people think, that the opportunity there is for sensor technologies to collect data remotely off these animals or the landscapes, and to allow producers to make way more refined decisions. There's also, to a certain degree, some real interest in automated management, so precision management, remote management technologies that will automate that as well. And so there's some real opportunities in Northern Australia to do that. The focus of what I'm going to talk about is on animal sensors, but I do just want to touch on some of the other technologies that will eventually be allied or potentially integrated in with those systems. And so we've got platforms, and I suspect you guys have some similar systems over there in Ireland, things like SIBO labs that's measuring productivity of pastures, and so using the Sentinel satellite system to make estimates of the feed base, how much feed's on offer, to make decisions around stocking rates. Also collecting data on measures of sustainability, so in this case ground cover. So there's a really big emerging push in the industry in Australia to look to improve our, I guess, our environmental credentials, both in terms of increasing productivity of landscapes, but also as a as part of social license and the pressures that are emerging on the industry there. And so some of the other technologies that are evolving in these big remote landscapes are things like remote weighing of animals. And so this is a walkover weigh system. So every day the cow walks across a weigh scale and gets measured for its live weight. It's a little bit like having your milk meters in the dairy. You can look at what's going on, and certainly when I was growing up on the dairy, we could lift the lid on the milk vat and look in and see that immediate feedback of the management strategies that we might have implemented that day or yesterday. And so if we hadn't fed them enough, then you could see that impact in the milk yields in the milk vat. Red meat producers, in particular in these extensive environments, just don't have that sort of information at the moment, but this is where these technologies walk over weigh, and there's other systems called walk-on weigh systems where they simply put their front feet up on a platform when they go in to eat some supplement, are really changing that and providing information on the productivity of animals, where really the only alternative for this is to go out and to muster animals. And like I mentioned before, people are really only doing that a couple of times of the year at most. There's just some weight data. But I guess the real focus of my research is around these on-animal sensors. And so the idea of having a device attached to the animal, which is providing information back to allow us to understand what's actually going on with that animal. And so you can see here a cow with one of the early ear-tag sensor systems that I've been involved in working with. Generally, how do they work? Basically, you've got that device on the animal. It's collecting data and then sending that off via either, say, a satellite or some sort of terrestrial radio system. The idea then is that data is analysed in the cloud, and that key information is then sent back to the producer on his smartphone or on a computer or whatever it happens to be. The key information, there's sort of three broad types of information that most of the commercial players are looking at, and certainly that we use. One is GPS or some sort of location type device, so where is the animal? The other one's the accelerometer or activity sensor, so movement, behaviour, and proximity sensors, which tell you whether an animal is near an asset or another animal. And what's really got to happen is, and what we spend a lot of time doing our research on, is taking the data off those devices, GPS location, accelerometer and proximity, and using that along with other information from other sensor systems, say like weather stations, and developing algorithms to turn that data into actually something that's going to inform a decision on the property. And I'll show you some of the things that producers are interested in. So there's several commercial systems out there emerging in the market in the red meat industry. And I should say, you guys will be familiar with a lot of the dairy systems have been around for quite some time in terms of leg tags and collars and whatnot. The beef industry is really pushing to get this into an ear tag format. So there's a little example of a Ceres smart tag. It's been developed for the beef industry. I've got a few other things lying around here. Can't find them right now, but we really want this as an ear tag form factor because that's what producers are familiar with. And also trying to keep collars on in some of these environments is a real challenge. We are exploring leg tags as an option, but really the industry wants this as an ear tag solution. This is a company called Smart Paddock that we work with quite closely, and I've got the system running at the moment. And for me right now, it means I can dial in, I can see exactly where my animals are in the paddock. and I can get some, at this stage, I can get some idea of their activity, although the data coming off these still needs a lot more work and algorithm development to make it useful. But at the very least, at the moment, we're using this to go out and find cows that are calving and locate them. I'll talk a little bit about what we're sort of doing in that space to take that to another level as well. I guess one of the big questions that we get asked quite a lot is, how will the industry actually get value out of this sort of data, this information? Where is it actually going to make a difference? And we've spent a little bit of time exploring that. We've done a bunch of survey work and some economic modelling. And we know that if we can get this sort of information to producers in the way that they can digest it, then there's a whole bunch of things that it could impact on. So everything from water-related behaviour, so knowing that cows have been able to get up and have a drink, that they've had access to water, welfare monitoring, mustering efficiency, just knowing where animals are in a paddock so that you can go out and actually round them up, muster them in. All the way through to a whole heap of other really interesting things like landscape utilisation, understanding where they're using parts of a paddock and where they're not, to optimise that. I'm just going to run through a couple of examples because we've actually worked with producers. We've put some of our research grade devices out there and actually given them a chance to explore the data off their own property and understand how they might sort of use that information. And so this is a station out at Longreach in the middle of Queensland, so a relatively arid sort of rangeland environment. And in this situation, they wanted to understand how they could use the data to detect whether an animal had had a drink at a water trough or not. And in this case, you can see these are two weaner lambs, and one's got into the water trough, which is the blue dot, the green sheep, but the red sheep's just walked straight past. And when we actually analysed that data, we found that one sheep hadn't actually gone to the water trough for 3 days, and there's some real problems with that. And so in that situation, the manager would have used that to change the flock structure a little bit to fix that. Some of the other things that are of real interest, we actually have quite a lot of stock theft in Australia. So I think Australia was largely founded on convicts, which were probably stealing sheep over in England or even Ireland, I suspect at some point. So we've seemed to have carried that over to here, and stock theft remains a really critical issue in a number of different areas in Australia. And so very simply looking at movement patterns that are associated with animals being interfered with in the paddock, or indeed, being put onto a truck and stolen. And so we've actually worked with producers to simulate stock theft events where they've stolen their own sheep, to show how that data can be utilised to detect and then alert to those particular events. Looking at things like detecting plant poisoning issues, so ryegrass staggers is Phalaris staggers and ryegrass staggers can be a real issue in some areas, and we were able to actually pick up behaviour changes associated with those particular diseases to, one day provide a warning. Actually looking at landscape utilisation, so where do animals graze in a paddock and where are they not grazing in a paddock? Because we're working at very low stocking rates, and so we're definitely not getting 100% utilisation. And thinking about, well, can we use this data to help locate where I put a new water trough if I'm going to put one in the paddock? And so there's a lot of interest in that. And there's certainly several people now using some of the commercial data coming off, say, Ceres tag to really explore these issues quite seriously, which is encouraging. Some of the other things that we're really interested in beyond the farm gate, so using this data further down the value chain, so things like objective measures of welfare. So I've actually worked with some companies looking at how we could take data from these devices and actually use it to inform a welfare measure for animals. Still a lot of work in that space, and whether this is the way the industry goes is up in the air. But obviously, government and regulators are really interested in the potential for this technology to take traceability systems to a whole new level. And so that's something that's absolutely being explored. We've got a couple of projects at the moment looking at that and the value of that data collected on a farm, on an animal on a farm, through to the processing sector and for the meat processor and onto the consumer as well. I guess the thing that I get excited about and thing I enjoy doing is this research, is the behavioural algorithm development. So you really, the data that streams off these sensor systems is obviously just a big string of noughts and ones when you take it back to the binary. And we've got to take that data and try and turn it into something that's actually useful. You know, for example, in this situation, alerting that there's cows calving. Producers are really interested in that data so that they can go out and intervene if there's a problem, or just know where that cow and calf is so that they can go and check on it. Or in the case of a lot of Northern Australia, we actually lose a lot of calves. A lot of calves die and we don't know why. And so to be able to know that a cow, say, had a calf successfully, but then maybe lost it a little while later, that's pretty useful information in our production systems. So we've done a lot of work around just basic behaviour modelling. So looking at the simple suite of standard behaviours that an animal sort of looks at. So things like standing, walking, grazing, lying, ruminating. We've got a project at the moment looking at licking, calf licking to measure that, and as an indicator that calf is actually being attended to by the cow. And this sort of information can then be fed into a range of other applications. I'll talk a little bit about that. Some of the other things that we're really interested in is this sort of parturition and gestosia detection, and we've got a range of projects over the years that we've looked at that and using the sensors to detect that. Predation is a really big issue in Australia. So we have a lot of wild dogs and dingoes, and they really do wreak havoc in some particular areas. And so actually having technologies to detect predation events, we've looked at that in sheep and cattle over the years. And the other big one's disease detection. And so we've looked at a lot of, a handful of infectious diseases. So things like bovine ephemeral fever and arbovirus that hits a lot of our cattle around here, lameness, and then through to like nematode infection, worm infection in sheep. And we're really looking at expanding that sort of work at the moment to try and see how far we can take the identification of these particular problems. So one of the ones we're working with in the US, the Ohio State Uni over there, looking at bull mating activity. So can we actually detect when the bull's serving cows so that we know that he's out there doing his job, or when he's broken down, has actually gone lame? We're doing a bit of work around that as well. I guess one of the things that I wanted to talk about a little bit in a little bit of detail is how we actually go about doing this. How do we actually go through our process? And so I'm going to talk about calving. You can see that calf drop out of the back end of that cow. So we've got a whole bunch of students and postdocs that sit out in the paddock at night with thermal cameras picking up imagery like this so that we can validate calving events. But it really starts with a lit review. So if we're interested in, say, detecting calving, we go back to the literature and do a systematic review and look at all the potential indicators that might give us an idea that that particular event has happened, whether it's a disease or a dystocia or whatever it is. And if you look at calving, two of the things that we're really interested in after doing a review on that was rumination and isolation. And Anita Chang actually has really focused on this particular area in her PhD, and has published a number of papers on it. So you can look up Anita's work if you're interested. From that lit review, we have a bit of an idea of the key behaviours that we're interested in. Then we go out and start looking at, well, how do we actually detect that? What sensors do we need? And in this case, we're looking for decreases in rumination, which the most likely sensor for that is the accelerometer, and then increases in isolation, so how animals interact with themselves and their landscape. So looking at GPS tracking to understand the relationship to other animals. In this case, we actually went and looked and spent some time developing our own rumination algorithm and sensor system off an accelerometer ear tag, a research grade one that we have. There's certainly some commercial products out there that can measure rumination, but they obviously, and it's proprietary in terms of the algorithms that they've got. And we're really interested in understanding how accurately we could actually get it, because we know some of the commercial platforms just out there, despite being reasonable at detecting rumination, are certainly not 100% accurate. So we decided to unpack that ourselves. You can see this cow, hopefully it's clear enough there. She's chewing her cud, and that's a trace of the accelerometer data on your screen there as it's going along. And the key thing to see there is you can see every time she chews, it's sort of, you're getting a chewing action. But then she stops to swallow and regurgitate, and you get a distinct change in the pattern as it dips down there. And in this case, we went and developed our algorithm using a range of different features out of the accelerometer. If you are into accelerometers, you'll know that they measure movement in 3 axes. There's some more complicated versions of it, but just forwards, backwards, up, down, and left and right. The acceleration, and from that you can create a whole heap of different what we call features, and that might be the minimum Z value over 5 seconds, or the maximum Y value over a minute, or the sum of the squares of all 3 axes over 10 seconds. And we create a whole heap of features and then feed that into some simple machine learning models. So in this case, we're using classification regression trees, and we've mucked around and looked at a whole bunch of different ones over the years. We're really focused on trying to find low energy, low computing power algorithms, because we ultimately want these running on the ear tag, and so they've got to be relatively simple. We're trying to find simple features that will describe particular behaviors, because if we can find a simple feature, there's a possibility also of just broadcasting that number off as well, and doing this post hoc in the cloud as well. We don't as yet play around with any of the more complicated time series machine learning stuff. It's something we're certainly looking at, but we've had reasonably good success with the process that we've got set up here. So we're changing and adapting, but what we've done so far seems to have worked okay. And so the process that we've got is we're getting 98% accuracy in detection of rumination. And then, like I showed you that image of that cow having a calf, we sit out in the paddock, watch cows have calves. Trying to find them in our paddocks is a bit of a challenge, but then we can validate how well that particular feature, in this case rumination, relates to that calving event. And you can see big differences around the day and the hour of calving with rumination. More than that, though, using one simple metric often isn't enough. We don't to absolutely get it right in terms of predicting the calving event. So this is where we start looking at bringing multiple bits of data together. And in this case, that isolation. So you can see on the map there's a cow in green. That's just a track of her day's worth of positions. And you can see she's snuck off to the side there, and she's having a calf. So she's left the rest of the mob. And so that's one thing we look at, nearest neighbour, so how close they are to other animals. Another one that we look at is movement constraints. So this is a minimum convex polygon of the GPS data of a paddock, and just shows you all those blue areas of the area utilised by the animal on a non-calving day, and the red is a calving day. So their area utilised shrinks down quite a lot. There you go, over time you can see that reduction. And then ultimately what we do is we take those different bits of data and those different algorithms that we might have developed, and we crunch them all together. Again, using machine learning. Sometimes we will apply just some basic heuristics on top of that to clean up some of the problems that you can get with it. We'll often bring in, and in this particular paper, Anita was bringing in walkover weigh data. So you remember back at the start, I talked about that, and weather data. And so animals obviously changing their behaviour in relationship to the weather. We bring that all together, and then from that, we're actually able to more accurately detect that calving event, and ultimately, the idea being is that we can fit these models either onto the device to some degree to feed off key data. Ultimately, they're going to have to come back to a cloud server to be integrated in with things like weather data that we can't get on the device. But ultimately, the idea is to provide that alert through to the producer. So we're sort of using that process across a range of different applications, whether it's the disease detection. We're doing a lot of work now in estrus detection to identify age of puberty in heifers using a similar model, and dystocia detection. So that's when cows are having trouble calving. And so looking at the degree of difficulty in the calving event, more than just, is there a dystocia? Do we have to pull that calf? We can have cows that will take a short period of time and seem to have an easy calving, and cows that take a long period of time and have a difficult calving. And that really impacts on that calf's likelihood of survival going ahead. And so we want to be able to quantify that as well. And so we're using that same sort of model or process, I should say, to explore that. Starting to look at cow-calf interactions. You can see that picture there. We've got a cow and a calf being tracked, and looking at how they interact once that calf's up and moving, and really exploring things like maternal investment. How does that cow invest into that calf and keep it alive, or not keep it alive, as the case is for some. So in terms of, I guess, where we're going with it, bigger picture, longer term, the real value is this bigger picture integration. And so looking at the integration of, say, the walkover weigh with the remote sensing, with the animal behaviour data. And this is just a little bit of a glimpse of this, some work I did on a Fulbright over in Ohio State, where we were integrating the pasture scanning data with the animal behaviour data to predict when animals needed to be rotated to a new paddock. And it's not rocket science. This is what producers do every day when they walk out into the paddock. They look at how much grass they've got, they look at how their cows are behaving, and they make that decision. But the sensor data can remotely alert them to, hopefully the odd occasion when they forget to go out and check, or they don't get to the paddock in time, and that can take that place and provide them a warning that, maybe they need to think about moving those cattle on. So big picture, one of the challenges at the moment for us in this space, dairy industry, you've got the sensors, you've got the collars, you've got tags, leg tags working out there in the industry. I've got friends that are running big dairies with those systems quite successfully. In our red meat industries, in these big landscapes, they're not really working 100% at the moment. So that's why I keep telling everybody this is sort of the phase that we're at. We're back in the brick phone phase at the moment, but one day we will get through to the iPhone phase, and we'll look back. I really think we'll look back and wonder how on earth we managed animals without the information that we had, a bit like we wonder how we ran our lives before an iPhone. I reckon there'll be some really good things that'll come out of it, and there'll be some unexpected bad things. Certainly producers, logging on and wondering and worrying about animals' data coming through that they never had to worry or wonder about before. There's some things we've got to think about. That wraps me up in terms of the presentation, but happy to take any questions that are out there.
Thank you very much, Mark, for your great talk. That was very interesting. So we have a first question in the chat, so maybe I will start with this question. So Joanna is asking, do you believe edge or fog computing cloud could improve the runtime performance of such systems?
Yeah, absolutely. So that's certainly something that we're interested in. The big challenges for us is data transfer in these remote areas. And so anything we can process on the animal or on a local sort of receiver tower at a water trough, whatever it happens to be, is critical. There's some really interesting applications in it, because some things we want to know right away. If it's a predation event and our cattle or sheep are being attacked by a wild dog, I want to know that right away now, so I can drive out there and try and shoot that dog. If it's a grazing distribution bit of information, I only want to know that at the end of the week or the end of the month. And so there's this whole range of different requirements for different sorts of data. Some of them need edge computing capacity. And we're starting to work more and more with our computational science group here, and the opportunities in that space are enormous. The challenges are enormous, but the opportunities are enormous as well.
Okay, thank you very much. So there's another question about the battery life on the GPS ear tags, and do they function well when they're near the buildings, handling facilities, etc. If you have something wrong or...
Yeah, so the battery life is a really excellent question, because that's one of the key constraints to any of these devices. So a lot of the tags that are in development are using a solar panel to harvest energy, and they've got a small battery or capacitor, whatever it happens to be, to store energy. And so it's a big trade-off between the weight of the device and the energy management, which comes down to also running the GPS, because they're very power hungry. So how often can you run the GPS? And at the end of the day, we've got to get these devices down to be as light as possible, because the ear tag retention is a problem, and so they must be small and light. In terms of that accuracy question around GPS, when we first started this, we would get GPS pings all over the place. The odd GPS ping would be 2 kilometers away, something like that. Made it look like aliens had abducted your cow, but it was just the error with the GPS. But now with the modern chipsets, we're really getting them down to be quite a lot more accurate. I just had a look at the system. These are still pinging away, and I noticed that it's dropped it straight on my office window, so they know where I am at the moment, down to a pretty accurate sort of level.
Thank you very much. You have another question. So yeah, it's about the commercial application of the system that you propose. How willing are farmers to pay for this solution, for example? It's suitable.
Yeah, so it comes down to the price structure really of these devices, and so it is definitely one of the big challenges. So at the moment, a Ceres tag is worth something like $250. And I know that's a real challenge for producers, but they're not going to go out and put one in every ear of every animal. But that's where we've been exploring things like what we'd call a sentinel deployment, where you might just put out 5 or 10% of your animals with tags, and you can get alerts to stock theft and stuff like that with that. There are other systems like the smart paddock guys that are working on cheaper chipsets, yes, it's really, I guess it's very early days. Pricing's still an issue, but people are still discovering the value, the return on that investment that they can get, and that's still yet to be, really explored.
Thank you very much. Another question about data ownership this time. So how is it handled, and is it a concern to farmers?
Yeah, it sort of isn't and isn't. We've got like farm data management policies which govern, how things are handled in certain by certain commercial providers and whatnot. But each of these commercial companies have a different model. So, for example, Smart Paddock and Movement, they tend to do everything in-house and they keep the data. Ceres Tag are completely different. They don't have a front-end data delivery service. They actually ask you to partner with somebody else, a third-party provider who handles your data and visualization of that data. So again, all different models out there. Are producers concerned about it? They probably they will be concerned if it ever gets to the point that this becomes a regulatory device in the context of a traceability system. Then it will be very interesting to see the the pushback from the industry, because the potential is for the government to know where each of your cows is, and that Australian producers are not that excited about that idea.
Thank you very much. I guess we don't have more. Oh, we have another one. Sorry. Is there any work done on fully passive RFID sensors?
Sorry, I didn't quite understand that one.
Sorry. Is there any work done on fully passive RFID sensors instead of GPS, I guess, so as an alternative?
Well, yeah, so I think if I understand that right, work around fully passive RFID. So we have a passive RFID National Livestock Identification System within Australia. So every cow, and soon to be every sheep, should have an electronic passive RFID tag in it. The challenge there is we've got low frequency tags, which the read distance is very short on that, which makes it difficult. We use them into systems like walkover weigh, so because the animal walks past a reader panel, we get data off that. I know they're looking at some of the high frequency passive tags, which allow you to get a longer read, and there's a lot of interest in that. Yeah.
Thank you very much. So we have no more questions at the moment. So I will ask you a question directly, more about the algorithm this time, actually. So, you know, you have mentioned the development of models to get the behaviors of livestock from accelerometer data specifically. Usually we have a lot of variability between animals. So basically what is happening is when you train a model with given animals and then you just apply your model to new animals, you have a drop of performance. So yeah, I would like to know if you experience this as well and how you plan to deal with this issue.
Yeah, so that's a really interesting one. So it's something that we've played around with a little bit. One of the so we get a drop in accuracy as well when we go from individual animal modeling to a herd or a group model. And there's a good paper put out by Anita Cheng around modeling rumination at those two different levels. It's worth a read if you get a chance. One of the things that I'm really quite interested in is, and some of our technology partners are doing this in other areas, it's this idea of self-calibration or crowdsourced calibrations to accurately, I guess, validate for each individual animal or to modify the algorithm for each individual animal. So for example, with rumination, I think from memory, if we do an individual animal model, it might be like 95% accurate. And that's about us having a little bit of observation data and looked at that animal and said, yes, that animal is ruminating now. That's what it looks like when it ruminates. Off we go. When we apply that across to the group, that accuracy falls away. But if we need it to be that accurate, then the opportunity might be for us to say, in a commercial context, work with a producer and ask them to provide a little bit of feedback on, is that animal ruminating? Oh, yes. And that bit of data can then feed back in to inform the model. At a bigger level, so that's at that sort of fine scale behavioural modelling sort of thing, we think the same thing's going to have to happen at the more applied level. So if you go and say, for example, calving detection, our calving detection algorithm might work really well in central Queensland, but if you drive 3 hours north into the Burdekin or whatever, something different about how the animals behave may throw that out. And in that situation there, again, you know, I think we're going to have to go to this. If a producer wants a really accurate algorithm, we might say, hey, we think cow number 23 is just calved. Can you go and check it? Yes, it has. Okay, let's redo our algorithm to take that crowdsourced information in as part of that as well. Okay,
interesting. So you think an idea will be finally to implement adaptive algorithm so that they continue to learn after commercial development. Yeah, okay, makes sense.
Yeah.
Thank you very
much. So that's happening with the, for example, with the remote sensing data that the company called SIBO Labs that we work with, they basically have a product that predicts your biomass, but you can also go out and take your own calibrating cuts, and eventually your calibrating cuts come back in and then refine not just your prediction, but actually your whole neighbourhood's prediction for biomass as well. So that it's a reasonably well established sort of, well, not reasonably, it's happening in other areas, I guess.
Okay, thank you very much. Okay, so there is no more questions, so maybe I can continue with another one. So you have just spoken about calving detection, so that's perfect for the transition. Basically we are collecting behaviors, and you said it's like kind of key indicators. And then I suppose the idea is to use these indicators to then provide an alert based on a change of this behavior, such as the drop of rumination that you have just shown. And so I'm wondering, which type of algorithm or methodology do you use as this plan to be able to say, okay, there's a drop of rumination clearly, so at this time we can consider that the cow is about to calve and stuff.
Yeah, so two things. We often will we have been using some fairly simple machine learning again. That once you've got to that process where you've got a whole bunch of time series data coming in, that's the opportunity. Or what we have previously looked at is I've forgotten the name of the algorithms, the change point analysis and all that sort of stuff that's out there. I know there's certainly more time series machine learning algorithms out there that we should be using, but we just haven't quite got there yet. That's where we should be going. But at the moment, we're having pretty good success where we simply just are using some pretty basic regression trees or random forests or SVMs, or even the good old, what do you call it? Linear discriminant, or linear discriminant analysis. And we're feeding those features in at a day step or an hour step, depending on what happens, and then predicting a state. Sometimes for some things, we will then go and say and then it becomes a heuristic process on top of that, where we say, oh, look, it's predicting that this cow is calving, and it's predicted that for the last 6 hours. Okay, let's call that the calving event. And that's very much just a very simple, heuristic process on top of that to tidy that up. So.
Okay, thank you very much. And so all the method where the animal is on reference, is on baseline, and so you just detect change from this animal, you think it's not maybe more promising than machine learning finally? In a context where there is a high variability between individuals, do you know what I mean?
Yeah, so sorry. Some of the features that we create are what we call delta herd and delta self features. So they will be, how have you changed from the same time as yesterday, but also how have you changed from the rest of the herd right now? And so that is definitely a big part of what we do, delta herd, delta self. To pick up that there's something wrong with, not wrong, but something's different about this animal at this time. Yeah,
I guess it's a huge challenge as well. Thank you very much for this. So we have no more questions. So I can continue with another one. Last question. So maybe I have last question just for you. As you are really close to the company field, so I have a question about I have the feeling that there are a lot of publications related to the development of models to get behaviors automatically or to detect an issue with animals. And compared to the tools available on the market, I would say there's a discrepancy between the two. And I'm just wondering, from your opinion, what is wrong, if it's, I don't know, a gap from the experimental field to the commercial application, which is not covered at all, or I don't know, communication between company and academia, I don't know, any clue.
So it's a couple of different contexts there. So if you look at the dairy industry, up until about 5 years ago, I might have my timing wrong, somebody probably knows this better than me, the dairy industry was really using the on-animal sensors simply for estrus detection, and then we started to get into the disease, subclinical mastitis detection, and I think now we're starting to roll on into different applications of that. Really, for me, in the red meat industry, we're still trying to solve the hardware problem. We don't have a fully reliable bit of hardware, an ear tag or a leg tag that's actually working for us. And so we do a lot of our algorithm development using research grade devices. So that's a GPS collar collecting data at a very high resolution, accelerometer ear tag collecting at a high resolution, which we can resample to mimic the commercial things as they come out. But I guess I'd sort of hoped that we would by now, you know, I've been mucking around in this area for say over 10 years. I'd hoped that we would have a bit of hardware, a commercial device that was out there working that we could have embedded algorithms on. We're nearly there. There are certainly some devices out there that are very, very close. There's just a few hiccups left to iron out. And then I think you will see, hopefully, the rapid integration of that knowledge that's been put out in publications into those commercial devices to make them actually more viable or offer more value to the industry at a greater rate than maybe even what has happened in the dairy industry with the sensors there.
Okay, thank you very much, Emma, for your great